This is going to be a little guided tour of my CNC system. It's now about 4 years old and is in its latest steel configuration. First of all, I think we'll look at the control unit. What you see on the front panel is the emergency stop, kill button, some little lamps telling you what's happening with various output supplies, a crest spindle output is indicated here, coolant, and there's a couple of 240 volt UK outlets here that can be used for ancillary equipments. Up here we've got a display which will show the voltages of the various DC power supplies in there that are used for different purposes. I'm going to switch the unit on now and I'll demonstrate that. At the moment it's indicating the stepper motor power supply unit, which is at 48 volts. The stepper motors themselves will handle about 60 volts, but the drivers I'm using at the moment cut off at 50 volts, so I've gone a couple of volts lower than that and powering them at 48 volts. This is showing the 24 volt power supply for the spindle motor which I've designed. It's a DC spindle motor and can be controlled directly from Mach 3. 12 volt supply which is powering some of the logic boards, and a 5 volt supply for the same purpose. Some logic boards require 5 volts and others 12. Coming out of the unit we've got the crest spindle supply, which will plug into a crest spindle motor which I have over here. Connector that plugs into there, and this runs, come out, from about 10,000 to 30,000 RPM. I've built my own little dust catcher thing there, a vacuum cleaner sucker goes on there, and I've got a brush arrangement to catch the dust, but that's used mainly for woods and plastics, rotating at high speed using router cutters, and sometimes I use a milling cutter which works quite well on plastics, especially if it's only 1 or 2 flutes. So that's that. This one, of course, you have to dial up the speed. You can't control it from Mach like you can with the one I've built myself. So you've just got to know what speed you want to run at and dial it up, and off it goes. This is the inside of the unit. And we've got the 4 stepper motor driver units here, X, 2 Ys and a Z, because I'm using a gantry type system which requires 2 Y motors, so hence 2 drivers. This is the supply for the actual drivers, the 48 volt supply. Over here is the 24 volt supply for the spindle. That's the breakout board which takes signals from the computer running Mach 3. This little setup is my own design to control the DC spindle, which also takes a signal from the Mach through the breakout board. It requires a pulse stream according to the speed you want to drive the spindle, uh, which is then compared with the feedback pulse from a chopper disc in the spindle motor. The two are compared, and the servo system controls the voltage to keep the motor at the correct speed. Relays which turn the motor on and off, and also reverse it if necessary. I can't see the reason why I would want to reverse it, but I just thought I'd put it in for completeness. This is the driver for the DC motor, controlled from the output of the control boards here. Now all this are coming out of the unit for the DC spindle motor. We've got power up on this white cable here, taking about 24 volts DC to the spindle motor here, and then back out of the spindle motor we've got a signal which is sensed by a chopper disc rotating in there and providing a signal back into here and it's compared with the pulse stream from Mach 3, and any discrepancy is amplified and used to control the speed of the actual spindle motor. I can't see it. These four connectors here are X, two Y's and a Z, and that is the power leads out for the stepper motors, and issuing from underneath and coming out. Going back up to the motors. The noise you hear is the ventilation fan which is on the top here. This little ducting box is taking fresh air from outside, uncontaminated by any dust that might be lurking about in the shed here, bringing the fresh air in, cooling it and escaping out the various little holes I've placed around the cabinet. Okay, I think we've booted, and here we have Mach 3 running. Using the manual data input tab here. So if we set the spindle speed to say 1000 and turn the motor on with M3, we've got the spindle running. Dial up 3000. We're down to 400, that's beg your pardon, that's 500. And then if we issue an M4 command, which is reverse, you may be able to see it reverse. Merely changes the polarity. Very simple. And then 5. That stops it. And using the jog commands, obviously we can move things left and right. Set up and down, and forward and back. And there you are, that's it all running. And there's Mach 3 up and running. We can't reset it because not need to turn on. Okay, we'll load program. Load G code. The motor pattern. There we are. Do it on that there, or off here. And it's program loaded. Well, here we are putting a taper on the outside diameter of this pattern for a stepper motor damper. $2,000 RPM indicated there. they are fitted. Parts I've just milled out, wired up, sockets connected, much more sturdy. Running there at about 2000 RPM. Just check. No, sorry, that's 3000. What you see in the back there is the Mach 3 settings. We've got the spindle to run at the correct S code. As you have seen, this machine will mill aluminium and aluminium alloys, pretty much any non-ferrous metal, but it will, if it's treated very carefully, mill steel. This is a piece of black mild steel, and as you see, it's milled this shape. I could come closer, but this camera needs a lot of light to focus closer. It's getting out of focus now. If anybody wants to see a closer shot of it, I can do that. But it's milled this crankshaft shape out of black mild steel with a few test cuts at the end there. And it's, as you see, it's quite successful. It's quite a nice finish and reasonably accurate. But with further improvement of the machine, I expect to do a bit better. So long as it's tread carefully and you don't go too mad with it, try and take too massive a cut off and get the right speeds and feeds correct, it does work. So I'm quite pleased with that. As I say, I hope to improve the machine to do a better quality, perhaps a little bit faster, but I'm quite pleased with that. Okay. A scooter motor, 200 watt. With it's driving a redundant AC Chinese spindle which is burnt out. So rather than throw it away, I've decided to press it into action, build it into a DC spindle motor, and it drives very nicely. There's plenty of inertia in the rotor, so that helps. And I've successfully milled quite a few things with that. Now I'll be putting them on the end of the video. Although I think they are, no, that's right, I'll be putting them on the end of the video and showing them this unit working. Was there anything else? Oh yes. So there's the timing belt and pulley system. Of course there's a timing pulley on the spindle of the motor, and also in there, I'll try and give you a look at it if I can get round. So I'm afraid that's the best I can do for a view of that. With there being such a low light here, I can't get a focus lock. Depth of focus is, I'll put it on manual. That's the best I can do. That's my own design of comparator board for the DC spindle motor. I actually milled that board out of a copper laminate. Sometime I'll show you how I did that. Didn't involve any masks or etching. It was simply milled out of a copper laminate, and it seems to work fine. To the left there is a 5-volt power supply. Up in the roof, up there, that's the 12-volt supply. And that's about everything explained. The back panel with its parts on, and a little reminder sticker on the back there for the stepper motor dip switches. Hope you enjoyed the demo.